Hey, welcome to this video on expression equivalence. Kind of holding court today. Kind of had fun with it. You know, you've heard the statement saying everybody is innocent until proven guilty. Well, all expressions are equivalent until proven unequivalent. All right? And what does it mean by equivalent expressions? Well, it's when any values are substituted for the variables, the results are equal. So let's say we have two expressions here. Okay, this one right here and this expression right here. Okay, we're going to determine whether these are the same expression, are they equivalent or not. And we're going to do this by finding a table of values, rewriting the expressions or simplifying them using properties, or we're going to use a graph of both expressions, and we're going to compare the graphs. Okay, so that's kind of like our evidence. Okay, so we're going to hold court today. First thing we're going to do is assemble our evidence. Okay, first we need to find our table of values, and the way we do this is we substitute the value for the x into this expression. So you can kind of see over here that we've done this. We put 0 in for x here and here, and then when we simplify this expression we get 4. So that's why I put 4 in this box. And then we did this again with 1, same expression, just a different variable value. So 1 plus 2 is 3. 3 plus 1 would be 3. 2 times 3 is 6. So 6 plus 3 is 9. Okay? And then again, we keep going until we get all of these numbers filled in. All right? And then over here, we do the same thing, but with this expression. So I put 0 in for x, and so 5 times 0 would be 0, so plus 4 would be 4. And notice they are the same thing. So it's looking pretty good here that they are equivalent. Well, let's keep going. So we put 1 in for x, and we get 9. So we put 9 in here. We put 2 in for x, we get 14. We put 14 here. We put 3 in for x, and we get 19. And when you notice, all the numbers line up. So what can you determine based on the values in the table? Well, we can determine they are equivalent, or they are equal. Right? Again, when any values were substituted for the variable, the results were equal. Okay, we got the same results here and here. Okay? Now, what would we need to do to verify that the expressions are equivalent? We would need to do every possible value of x. Now, that would be a doozy of a homework assignment. Okay, that would be never ending. So we're not going to do that to you. So let's look for some other evidence. But we do have our table of values done. Check. Now, let's talk about simplifying this expression. So let's look at a more complicated expression. Okay, and if we do use our properties from yesterday, we can decide whether they are equivalent or not. So I'm going to start with the given, and then from this step to this step, it looks like they're doing the distributive property. So I do 2 times x, and then 2 times 2, which is 4, plus 3x. All right? And then they say to combine like terms, so sure enough, 3x plus 2x would give me 5x plus 4. Now, if 5x plus 4 sounds familiar to you, it's because it was this expression right here. So underneath all of this, all these layers, we ended up with 5x plus 4. Okay? So are the two expressions equivalent? Well, yes, because when they're simplified, they are the same. And when the more complicated expression was simplified, we found the simpler expression. Okay, so it's looking really good. 2 points of evidence are saying that they are equivalent. Last one, graphing. Okay, so we want to plot our points using our data table over here. So when x is 0, we put that value in for here. This value is going to be our y. So when x is 0, our y was 4, and we put a box there. When x was 1, y was 9, so we put a box there. And then when x is 2, y was 14, so we put a box there. And when x is 3, y was 19, so we put a box there. And then what we found out was our triangles are going to be the same exact points, meaning these lines are identical. So how does the graph demonstrate that the expressions are equivalent? Well, they are the same line. If it's the same line, it must be the same expression. Okay? So all 3 of our tests indicate the same thing, that these are equivalent. So we can assume that these two expressions are in fact equivalent. Right? Then I gave you a chance to try the next one on your own or as tables. And we found out that as you enter these values that they are not the same. Okay? the table is not looking like they're equivalent. So we said they're probably not equivalent. And then we did the distributive property with the more complicated expression, and we found 2x plus 10. 2x plus 10 is not equal to 2x plus 5, which was the other expression. So no, the simplified expression is not the same as the other expression. Okay, and then continuing on with our graph, we found that these two lines are not the same line. One's down here and one's up here. So they are not the same line. This does not look like these two expressions are equivalent. Okay, so that leads us to your assignment, which was page 58 through 60, doing question 9 through 10. All right, so it looks like basically the same thing as what we were doing. All right, you're going to use a table, properties, graph. Table, properties, and graph. All right, thank you for watching.